Okay, so we're going to spend a couple of days factoring on the 4 different types. So we're going to really mix it up today. Well, as we're factoring, I want to keep in mind our little guide here as we do a little checklist. So we always check to see if there's a GCF first. No matter which factoring it is, we always check to see if there's a GCF, if there's anything in common between however many variables there are. After I've checked for a GCF, it could be one of 4 factorings, okay? The first one we talked about was difference of 2 squares. That means there are 2 perfect squares being subtracted. If they're not 2 perfect squares that are being subtracted, then chances are it's just a GCF problem. If we check the GCF and it's a trinomial, that means 3 terms. The regular trinomial or basic trinomial is whenever it's just a 1 in the very front. And that's when we just go over those rules again that we've talked about. Then the third type is if I've checked for the GCF, it's a trinomial, but there's still a number out in front of the first term. Then we do our slip and slide trinomial, which we'll go over again. The fourth type and final type is after we've checked for a GCF and there are 4 terms, we are going to factor by grouping. And that's when we group the first 2 terms together and the last 2 terms together. But you can always keep in mind after we factor what we have, always check to see if there's another type of factoring within that problem. But that doesn't happen very often. So let's just get started. If I look at number 1, we're first going to check for a GCF, always. So 28 and 63, if I'm not mistaken, have a GCF of, let's see, 63, trying to think, 63 divided by, there we go. So 28 and 63 both have a GCF of 7. And then a squared b and b have a GCF of b. So let's see what's remaining. 28a squared b divided by 7b is 4a squared. And then negative 63b divided by 7b is negative 9. So after I've checked the GCF, I'm going to see which one of the 4 this applies to. Since it's only 2 terms, the only one it can apply to is difference of squares. But we need to make sure it is actually. 4 and 9 are perfect squares, so that checks off. A squared is an even exponent, so yay. And it is subtracting. So this is a dot. So I'm going to leave my GCF out in front. I'm going to break this up into 2 binomials. So ask yourself this question. What times itself equals 4? And 2 times 2 does. What times itself equals a squared, and a times a does. What times itself is 9, and 3 times 3 does. Now, dot means a difference of 2 squares. To get that negative 9, one has to be a positive and one has to be a negative. And that's my answer. There's not another factoring within this problem, so we can move on. If I look at number 2, first we want to check for a GCF. 3, 9, and negative 30 have a GCF of 3. So let's see what's remaining. 3m squared divided by 3 is m squared. 9m divided by 3 is positive 3m. And negative 30 divided by 3 is negative 10. So I look to see what I have inside my parentheses. And this is a trinomial. Well, which one is it? Basic or slip and slide? Since there's nothing in front of the m at the very front, this is a basic. So we're going to break this up into 2 binomials. M times m. Since c is negative, that means one's going to be positive, one's going to be negative. What multiplies to get 10 but subtracts to get 3? Multiplies to get 10 but subtracts to get 3. And the 2 numbers that come to mind are 5 and 2. Because 5 times 2 is 10 and 5 minus 2 is 3. Now, since these are different, 5 is the bigger number. And I'm going to put 5 with the sign that b is. So I'm going to put positive 5 and negative 2. And there's my answer. We're done. Number 3, first we check for a GCF. This one does not have a GCF because 1, 2, negative 4, negative 8. 1 would be the GCF, but we don't want to bring out a 1. All of them have x's except the last term, and all of them have y's except the first term. So this is not a GCF, or doesn't have a GCF. But how many terms are there? 1, 2, 3, 4. If it's a 4 term, then it's factoring by grouping. So we just covered this. We're going to break this up into 2 binomials. First 2 terms, last 2 terms. And notice I put the sign in front with it. So now let's look for the GCF of each binomial. So even though it didn't have a GCF all 4 terms, there is a GCF with these 2 terms. So x cubed and 2x squared y have a GCF of x squared. So x cubed divided by x squared is x. 2x squared divided by 2x squared y divided by x squared is positive 2y. On the right side, negative 4x and negative 8y have a GCF of negative 4. And negative 4x divided by negative 4 is x. Negative 8y divided by negative 4 is positive 2y. And if I do it correctly, my 2 binomials end up being the same. So all I have to do is pull my GCFs together. So x squared minus 4 makes up my first binomial. And then my second binomial is x plus 2y. Now, normally I would be done, but I noticed something on this right here. If you look at x squared minus 4, I have a dot within my grouping. So what happens here, this is x squared is a perfect square, 4 is a perfect square, and it's subtraction. Dots are the ones that pop up within other problems. So you really have to look for a dot on every kind of problem, even if you think you're done. So I'm going to break up this dot into 2 more binomials. So what times itself equals x squared? X times x. What times itself equals 4? 2 times 2. And to be a dot, one's positive, one's negative. Now, I still have this one out to the side. It's still part of it, but that dot broke up even more. So that's just a step further. So always look out for dots. Number 4. Doesn't have a GCF because 4, 7, and 2 don't have a GCF in common. So if I can't go any further, this is a trinomial, which means it's either a basic trinomial or a slip and slide. Since I have a number out in front, this is a slip and slide. So we're going to slip the 4 to the 2. So I have y squared plus 7y. 4 times negative 2 is negative 8. Now it becomes a basic trinomial. So I'm going to break this up into 2 binomials. Y squared times y is y squared. Since c is negative, one's going to be positive, one's going to be negative. What multiplies to get 8 but subtracts to get 7? And the 2 numbers that come to mind are 8 and 1. Since 8 is the larger number, I'm going to put it with the sign that b is. So 8 is going to be positive and 1 is going to be negative. But this is a slip and slide. If you remember, we have to bring this 4 back as a denominator to both terms and simplify where needed. For instance, 8 over 4 simplifies to 2. 1 over 4 does not simplify, but here's where the slide comes in. I'm going to slide the denominators back to the front. Well, since y plus 2 doesn't have a denominator, it's just y plus 2. But right here, 4 is the denominator, and I'm going to slide that back to the front, so it becomes 4y minus 1. And of course, I can check my work by foiling this out and seeing if I end up back at where I started. Number 5, let's first check for a GCF. So the GCF of 48 and 3, and 48y to the 5th and 3w is 3w. 48w to the 5th divided by 3w is 16w to the 4th. Negative 3w divided by 3w is negative 1. So we had a GCF here, and I'm left with a binomial. Now, the only thing it could be is difference of 2 squares. But let's see if it meets the criteria. 16 is a perfect square, 1 is a perfect square. The exponent is even, and it's subtraction. So yes, this is a dot. So I'm going to break this up into 2 binomials. What times itself is 16? 4. What times itself is w to the 4th? W squared. What times itself is 1? 1, and since it's a minus, we have to do plus minus. Now, you think we're done, but we're not done yet. There is a dot within a dot on this one. Yes, I said it. So 3w, I'm going to bring down. 4w squared plus 1, I'm going to bring down. But right here, this is a dot within another dot. Here's why. 4 is perfect square, 1 is a perfect square. The exponent is even, and it's subtraction. This is not a dot because of the addition. So I'm going to break this one even further into 2 binomials. What times itself is 4? 2. What times itself is w squared? W. And what times itself is 1? 1. And since it's a dot, it's plus minus. So this one was, wow, a little lengthy, but not too hard if you know what to look for when we're talking about dots. So a dot within a dot. Who knew? If I look at number 6, we have 24, 6, and 3. All three have a GCF of 3. X squared, y squared, xy squared, and xy have a GCF of xy. So if I look at what's remaining, 24x squared y squared divided by 3xy is 8xy. Negative 6xy squared divided by 3xy is negative 2y. And 3xy divided by 3xy is positive 1. Whew. All right. So now we're left with a so this is not one of those cases where we consider a trinomial, okay? And the reason why we don't consider a trinomial is because we don't have an x squared up here. So that's the only reason. This one only was a GCF, which is possible. Number 7, 8x to the 4th, negative 4x cubed, and negative 24x squared have a GCF of 4x squared. If I look at what's remaining, 8x to the 4th divided by 4x squared is 2x squared. Negative 4x cubed divided by 4x squared is negative x. And negative 24x squared divided by 4x is negative 6. Woo! Now that we have the GCF taken care of, this is a trinomial. But which kind of trinomial? Since I still have a number out in front, this is a slip and slide. So we're going to slip this 2 to the 6, and I have x squared minus x. 2 times 6 is negative 12. So I'm going to break that up into two binomials, x times x. Since c is negative, I'm going to do a plus minus. What multiplies times 12 but subtracts to get 1? And the two numbers that come up are 4 and 3. But since 4 is the bigger number, I have to put it with the sign that b is. So 4 is actually going to be negative here, and 3 is actually going to be positive. This was a slip and slide, so that means I need to bring this 2 back as a denominator. 3 over 2 does not simplify, but 4 over 2 simplifies to 2. So let's see what I'm left with. I didn't leave myself enough space. I have 4x squared, okay? My first binomial, I'm going to slide that 2 back to the front, so 2x plus 3. The second binomial, there was no denominator because it simplified to x minus 2, so my second binomial is x minus 2. Sorry for the mix there. Number 8, 64x squared minus 4y squared, GCF is 4, so then I'm going to break that up. 64x squared divided by 4 is 16x squared. Negative 4y squared divided by 4 is negative 1y squared. Now again, after I've taken care of the GCF, I look at my two terms, and this is a binomial. The only thing it could possibly be is a dot, a difference of two squares. So let's see if it meets the criteria. 16 is a perfect square, 1 is a perfect square. X has an even exponent, y has an even exponent, and it's subtraction. So guess what? This is a dot. What times itself is 16? 4. What times itself is x squared? X. What times itself is y squared? Y. And then plus minus. And be glad this is not a dot within a dot, so we are done. Number 9. No GCF between x cubed 3x squared minus 5x minus 15, but this is 4 terms, so this is a factor by grouping. So x cubed plus 3x squared has a GCF of x squared. What I'm left with is x cubed divided by x squared is x, 3x squared divided by x squared is positive 3. On the right side, negative 5x and negative 15 have a GCF of minus 5 because negative 5x divided by negative 5 is x and negative 15 divided by negative 5 is positive 3. Since my binomials ended up being the same, that means I did do them properly. So I'm going to bring my GCFs together. X squared minus 5 makes up my first binomial, and then x plus 3 makes up my second binomial. Now at first it looks like this might be a dot, but if I look carefully, yes, x has an even exponent, but 5 is not a perfect square, so I can stop there. If I look at number 10, there is no GCF between k squared, negative 6k, negative 16, but this is a trinomial. Let's see what kind of trinomial. Since there's not anything in front of k squared, it's a basic trinomial. So I can jump right into finding my two binomials. K times K. Since C is negative, that means it's going to be positive, negative. What multiplies to get 16 but subtracts to get 6? And the two numbers that come up are 8 and 2. Since 8 is the larger number, 8 has to be the same sign that B is. So 8 has to be negative and 2 has to be positive. This was not a slip and slide, so I don't have to worry about any denominators. Just getting more practice here. If I look at number 11, AB squared minus A have a GCF of A. So if I look at what's left, AB squared divided by A is B squared. Negative A divided by A is negative 1. And then it looks like there wouldn't be anything else. But like I said, that dot likes to sneak up on you. This is a dot because B has an even exponent. 1 is perfect square and it's subtraction. So if I break this up, what times itself is B squared? B. What times itself is 1? 1. And since it's a dot, it's positive, negative. Now I'm done. Number 12, 9y squared minus 12y plus 4 does not have a GCF. So I look at it and it's a trinomial. But this would be a slip and slide trinomial because I still have this 9 in front. So we're going to slip that 9 to the end. I have y squared minus 12y. 9 times 4 is positive 36. Now I can break it up into two binomials. So since C is positive this time, that means they're both going to be positive or both going to be negative. Since the B is negative, that means they're both going to be negative. That's my giveaway. Well, it multiplies to get 36 but adds to get 12. And the two numbers that come up are 6 and 6. So it doesn't matter where I put the 6 and 6 because they're both the same value and they're both negative. This was a slip and slide, however, so I do have to bring that 9 back as a denominator. 6 over 9 simplifies to 2/3, just like 6 over 9 simplifies to 2/3. Now, this is where we slide the denominators back to the front. So, 3y minus 2 and 3y minus 2. This is not a dot, but I could see this written a different way. Since these are exactly the same binomial, you could see it written 3y squared. Just FYI. Number 13, 24ab plus 30ac has a GCF of 6a. If I look at what's left, 24ab divided by 6a is 4b. 30ac divided by 6a is positive 5c. And at first, we want to check to see if it's a dot because it's a binomial, but this is not a binomial, by far a binomial. So this only was a GCF. Number 14, there is no GCF between all four values, so this has to be a grouping because it's 4 terms. 9x cubed and 9x squared y have a GCF of 9x squared. 9x cubed divided by 9x squared is x. 9x squared y divided by 9x is positive y. On the right side, my GCF between negative x and negative y is negative 1 because I don't want that to be the negative x to be a negative. So in order to do that is to divide by negative 1. Negative x divided by negative 1 makes it positive x, and negative y divided by negative 1 makes it positive y. And if you look, my two binomials end up being the same. So I'm going to bring my GCFs together, 9x squared minus 1 and x plus y. But wait, we're not done because guess what? There's a dot creeping up on us. Okay, 9 is a perfect square, 1 is a perfect square. The exponent is even and it's subtraction. So now I can break this one up into two binomials. What times itself is 9? 3. What times itself is x squared? X. What times itself is 1? 1. And since it's a dot, it's plus minus. Now I still have this x plus y out to the side, so don't forget that it was there. We just had to break down the dot. Number 15, it's a trinomial, but we have to check to see if it's a GCF. It does have a GCF of x. X cubed divided by x is x squared. Negative 10x squared divided by x is negative 5x. And 21x divided by x is positive 21. Now I can see the trinomial. And this is a basic trinomial because there is nothing in front of the x. So I'm going to go ahead and break it up into two binomials. Since C is positive, that means they're both going to be positive or both going to be negative. B tells me that they're both going to be negative. Well, it multiplies to get 21, but adds to get 5. Multiplies to get 21, but adds to get 5. Make sure I did this correctly. Oh my goodness. Sorry, this is supposed to be 10. I don't know what I did there. So, sorry, what adds to get 21, but, sorry, multiplies to get 21, but adds to get 10 is 7 and 3. I knew my math was wrong somewhere. And since both are negative, it doesn't matter where I put the 7 and the 3. And then I'm done because this wasn't a slip and slide. There is not a dot, so we're done with that one. Number 16, 6y cubed and negative 150y. If we look for a GCF, this has a GCF of 6y. 6y cubed divided by 6y is y squared. 150y divided by 6y is negative 25. And then I look, and this is a binomial, so we always check to see if it's a dot. Y has an even exponent, 25 is a perfect square, and it's subtraction. So we can break this up further into two binomials. What times itself is y squared? Y. What times itself is 25? 5. Since it's a dot, one's plus, one's minus. There's not another dot in there, so we can move on. Number 17. There is no GCF. So if I'm left with a trinomial and I have a number out in front, this is a slip and slide. So we're going to slip that 8 to the 3. So it becomes m squared plus 2m. 8 times negative 3 is negative 24. Now I can break it up into two binomials. So since c is negative, one's going to be positive, one's going to be negative. What multiplies to get 24 but subtracts to get 2? Multiplies to get 24 but subtracts to get 2. And the two numbers that come up are 6 and 4. Since 6 is the larger number, it has to take the sign of b. So 6 has to be positive and 4 has to be negative. Keep in mind this was a slip and slide. So I have to bring that 8 back as a denominator and see if I can simplify. 6 over 8 simplifies to 3 over 4. 4 over 8 simplifies to 1/2. So I'm going to slide the 4 to the front, 4m plus 3, and then 2 to the front, 2m minus 1. And there's my two binomials, and there's not another dot, so we can move on. All right, number 18 has a GCF of 2. So let's see what's remaining. 2w squared divided by 2 is w squared. 38w divided by 2 is, I believe, 19. And 140 divided by 2 is positive 70. Yep. So now it's a basic trinomial because the GCF took care of the slip and slide part. So since c is positive, that means they're both going to be the same. B tells me that they're both going to be positive. Well, it multiplies to get 70 but adds to get 19. Multiplies to get 70 but adds to get 19. Let's see, 7 and 10 wouldn't work. 70 divided by... There it is. 14 and 5. Since 14 and 5, both of them are going to be positive, it doesn't matter where I put them. This was not a slip and slide. There is not a dot, so we are done factoring with that one.